Step outside on a clear night and look up. Every star you can name, every constellation, and every point of light visible to the naked eye resides tightly within the boundaries of our own Milky Way galaxy. Our galaxy is a single island of stars in a universe filled with hundreds of billions of others. While the Milky Way stretches 100,000 light-years across, that distance is a minor calculation compared to the gulfs of space that lie beyond it. The Andromeda Galaxy, our nearest large neighbor, sits 2.5 million light-years away. Light moves at 186,000 miles per second, yet it must travel for 2.5 million years just across the gap between us. For a human driver at highway speeds, that same journey would take more than 500 trillion years. Astronomers call the region between these galactic islands intergalactic space. It is the most desolate environment in existence. While the space between stars in our galaxy contains about 1 atom per cubic centimeter, the deep stretches between galaxies contain less than 1 atom per cubic meter. To understand the architecture of the cosmos, we have to look past the glowing galaxies and confront the sheer nothingness that separates them. Galaxies do not drift randomly through the dark. Over billions of years, gravity organizes them into bound groups, massive clusters, and superclusters. Our own Milky Way belongs to the local group, which is currently falling toward the massive Virgo supercluster. This is the cosmic web, the universe's largest structure. Dense nodes of galaxies are linked by filaments of dark matter and gas. These visible threads occupy only 20% of the volume. The remaining 80% is the dark, negative spaces between them. These regions are called cosmic voids. They are physical environments where matter has been pulled away by the gravity of the surrounding filaments. In the center of a void, density is so low that a volume the size of a wardrobe might contain only a single hydrogen atom. In terms of volume, the void is the standard state of the universe. Our crowded, light-filled galactic neighborhood is a highly atypical environment, existing only in the thin walls of the cosmic web. The empty space within these voids is physically stretching. Every cubic meter of intergalactic space is expanding, causing the distances between galaxy clusters to grow every second. This expansion was first measured by Edwin Hubble in the 1920s. By analyzing the light from distant galaxies, he found their wavelengths were stretched and reddened, proving that the space between us and them was actively growing. We now know this expansion is accelerating, driven by an unseen force called dark energy. Making up 68% of the universe's energy content, it pushes the cosmic voids wider at a rate that increases over time. This shows the result. Eventually, space between us and distant galaxies grows so fast that the distance increases faster than light travels. When a galaxy crosses a boundary called the cosmic horizon, its light can no longer bridge the gap, vanishing from view permanently. This process turns the expanding distance between galaxies into a closing door. Over trillions of years, dark energy will move the rest of the cosmos beyond our reach, leaving our local neighborhood in total isolation. Within our own neighborhood, gravity is currently winning. In about 4.5 billion years, the Milky Way and Andromeda will collide and merge, eventually forming a single massive elliptical galaxy known as Milkdromeda. While our local stars consolidate, the rest of the universe will continue to drift away. Every galaxy cluster outside our gravitationally bound group is receding toward the cosmic horizon. In the far future, the expansion of the voids will carry every other galaxy out of sight. Any inhabitants of Milkdromeda will see a perfectly black sky beyond their own stars, with no physical evidence that other galaxies ever existed. Our current view is different. We can still catch photons that have traveled billions of light-years across the expanding void. To register these signals, the mirrors of the James Webb Space Telescope must be precise enough to collect energy that left its source when the first galaxies were still forming. We exist in a specific window of time, where the universe is old enough to have formed complex structures, but young enough that they remain visible. We are in the only epoch where a species can look across the void and map the 93 billion light-year span of the observable universe.